Hello and welcome to another Zozin session. How about that? How about that? I bet you didn't expect that shit to happen. So today I wanted to take a look at something that I wanted to look for quite some time already. And that thing is metaballs. Right? Have you guys heard about metaballs? So basically it's an organic looking and dimensional isosurfaces. I don't know what the fuck is isosurfaces, but this shit looks cool. So, and I basically wanted to code that somehow, and looks like it's relatively easy to code. So here is an example on Wikipedia for like a three-dimensional spheres and stuff like that, but we're going to be doing that in 2 dimensions. Right. We're going to be doing all of that in 2 dimensions. And it looks like the chat is dead. So maybe I need to just check something. Yeah, the chat is dead apparently. That's really strange. So let's actually maybe try to fix that. Is there any way for me to refresh the page, the current page? There's no way to refresh the page. Okay, so maybe I now can do something like this. No, it doesn't work. Thank you so much, Streamlabs. Very cool. We cannot have chat today. Well, I mean, I can do a pretty dangerous thing of actually putting the chat in front of my face, and I will get angry because people will try to piss me off all the time. So I don't know what we're gonna do about that. I don't know what we're gonna be doing about that. So one of the things I can try to do is maybe switch the browser that I usually use. It's so annoying. OBS is so annoying actually. Okay, shut down the source when it's not visible, and I'm gonna just hide the chat and reopen it again. And what if I try to do this kind of thing? And it just simply doesn't work. It simply doesn't work. Okay, fuck the chat then. So we're not gonna be doing that with the chat. All right. So what I wanted to do is I wanted to actually put the this thing in the description, right? So let's actually put that in the description. So metaballs, there we go, metaballs. So we need to decide how we're going to be coding all of that. We're going to be probably doing all of that maybe with OpenGL, or maybe pixel by pixel on a CPU, right? So pixel by pixel on a CPU. So which one is the better way of doing that? Which one is the better way of doing that? You know what? Maybe not fuck the chat. So maybe I'm gonna do just like the color source, and I'm gonna put the chat somewhere here. There we go. So I'm probably gonna regret that, but hey, what do you do when the computers actually fail you completely? So yeah. So let me see. So maybe we can try to do on the CPU. I still haven't decided where I want to do that, on the CPU or on the GPU. On the CPU or on the GPU. So maybe I'm gonna do that on the CPU. Yeah, because GPU is too easy, right? So let's actually do that somewhere else. So and let me see. So what we're gonna have in here? So it's gonna be make dir. And so the thing is, let's actually call it metaballs, right? So this is the metaballs, and maybe I'm going to simply start this entire thing. Okay, so main.c. So we're gonna include stdio and stdlib, right? So we can try to basically render the thing into a back buffer and just save that back buffer as a ppm, as we usually do. But again, we've already done that so many times. Maybe we're gonna just render directly in the X11 window. So that sounds like a plan, actually. That sounds like a plan. Let's actually do X11 thingy. But first of all, let's establish the compilation of our nation. So it's going to be hello world, right? And let me create a make file, super quick. Metaballs main.c. So this is the C compiler, this is the C flags, and metaballs. Do we need anything else in here? So maybe we'll need the... let's actually put all of the linker flags into the libs, right? So this is going to be something like this. So this is going to be flags, and we're going to have w-all, w-extra, right, extra. Then what we're going to use as the standard C11, I suppose, and we're going to be pedantic about it, pedantic about it. Pedantic. And the next thing we want to do, in case we want to debug something, I'm going to be actually, you know, supplying this flag. Right, for the libraries, we're going to be using the math library, and since I want to do X11 rendering, I'm going to be also linking with the X11, right? So, and let's try to compile the entire thing, and first try, would you look at that? We actually first tried this entire thing. So, setting up X11 is a huge pain in the ass, so I'm going to be basically copy-pasting X11 setup from one of my previous projects, which is called Tiles. If you're interested in this project, you can check it out here. Right, and for lovely people who's watching me on YouTube, who I like more than Twitch people, by the way, because at least they're not trying to piss me off all the time. So I'm going to put this thing in the description. So, Tiles source code, right, Tiles source code. So maybe I'm going to actually disable white spaces in here, and so this project is actually rather simple, right? So let's take a look at this thing, Tiles, and right, so it basically, yeah, it basically renders the like different patterns with Tiles and whatnot, and it uses like X11 system directly, like it opens X11 window and stuff like that, and I'm going to be copy pasting the code from there. So let me just go to this entire project, and let's just copy paste a bunch of code. I think the code for live rendering is located somewhere here. So here we're opening the display, and then creating a window, then we're getting the attributes, we're creating the image. Image, by the way, is basically array of pixels, right? And I want to render the metaball into that array of pixels, right? And then once you create such image, you will be able to actually bleed that image into a window. So GC stands for graphics context, not the garbage collector. So it's a thing that you need in X11 to actually draw things. Then some X11 protocol bullshit to actually be able to close the window. Then selecting the input, showing the window, and then organizing the event loop and rendering and stuff like that. And finally closing the entire display. So this is basically what we need in here. And I'm going to simply copy paste this entire thing because, you know, the most reusable code is the one that you can simply copy paste, right? Not the abstract one with a lot of, you know, classes, with a lot of base classes, generics, templates, contracts, code generation. No. This is not the most reusable code. The most reusable code is the one that you can just, right? And then adapt to your needs. That's a truly reusable code. None of that abstract bullshit, okay? So, now let's actually adapt this entire thing to our project. So we open the display, and then we check that we managed to open display. So we don't really need more control over the visual or something like that, because this is a throwaway project, so fuck that. So here we have the resolution. So what I'm thinking is that maybe I'm gonna actually do something like width and height, right? And for width and height, I'm gonna be using something more modern than 800 by 600, because what year is it? 1918? Come on. So it has to be 1600 by 900, right? 1600 by 900. That's a modern resolution. That's a modern resolution. Alright, so that looks good. So by order of the pixel difference between the renderer, well, it's not a problem for us. Shiggy man! Oh my god! Thank you so much.
Hi.
Hi, thank you so much for 8 months of tier 1 subscription. Thank you, and welcome to our Epic C Programming Club. Alright, so here we're gonna have the following thing. So here we specify the basically the what is it called, the back buffer into which we're rendering everything, right? So this is probably what we want to do in here. Okay, so let's actually create the static back buffer. So this is going to be static uint32 pixels, right? So, and the amount of pixels we have in here is width, byte, height. Right, there we go. So, and then I'm going to be putting this thing in here. So this is going to be the pixels, and then we're going to have a width, width and height. Width and height. And then here we provide, I think, the stride, right? So the stride is essentially basically width by RGBA32. So in my previous project from where I copy pasted, I have this type called RGBA32. So I'm thinking, is that a good idea to introduce it? The problem is that the X11 and like other systems, they have different order of like bytes and stuff like that, basically the formats of the pixel. So I'm not really sure if it makes sense to put the format of the pixel into the name of the type, right? So maybe I'm going to introduce something like uint32t pixel 32, right? So this is going to be pixel 32. Right, so the only thing we know about that thing is that it's 32-bit long, right? So it's a 32-bit pixel. So, and specific format doesn't really matter, so we're gonna ignore the specific format, right? So this one is gonna be pixel 32. Pixel 32, so we create the garbage collector, right? So then we create this kind of bullshit, then we select the input. So I'm not sure. I just realized that this is the old version of the code, because in the newer version of WangTiles, I actually set handling of key presses, right? I set handling of key presses because I wanted to be able to handle such thing as Q to quit the application. So I guess I forgot to fetch the latest changes. I guess that's what I forgot to do, but maybe we can do something at some point. Okay, so here we're organizing the event loop, and to do, do we need this to do? I don't think we need this to do. So here we get the current time. So this is basically a global time, which is fine, I suppose, but here we have this thing in seconds, right? And I basically take the nanoseconds and I bring all of that to fractional part. So basically I track the global time in seconds in a floating point number, right? In a floating point number. And the reason why it is a floating point number is because I want to be doing, you know, different arithmetic operations on this kind of thing. Yeah, I want to use it for animations, but I'm not sure if I want to use this thing for animations in this specific case. Do I want to keep track of this thing? Do I really want to keep track of these things? It's a tough question. It's a very, very tough question. So I can probably... Maybe we're going to be doing animation actually. So I think once we code the metaballs, we can try to do some sort of an animation. And to do animations, you need to keep track of time. So let's actually introduce something like a global time in here. So this is going to be float global time. Initially, it's going to be 0, right? So here's the global time. And then we take the current time, and I'm going to be assigning all of that to the global time. I'm not sure if I want to make this kind of, you know, resolution. Let's do the following thing. So let's actually also keep track of all of the nanoseconds. 1, 2, 3, 1, 2, 3. I hope the resolution of float is actually enough to keep track of this kind of thing, so we'll hope that it is. So layering transition between, well, this is not relevant. We don't have any of these things in here, and the width and height in this particular case is just width, and this entire thing is just height. There we go. And then we close the display. There we go. We did an X11 application by copy pasting the code. Let's see if it's compiling or not. It's almost compiling, so we don't have uint32 underscore t because we need to include stdint, right? We need to include stdint. So we don't have a display because we need to include x11 xlib, I think that's what you have to include. So this thing requires time, so let's include time. All right, so another thing, it's a clock. Oh, I do remember, by the way. Yep, clock. Yep, clock. Okay, so I think you have to define the POSIX shit, right? Yeah, so we have to define this shit, otherwise it's not gonna... Well, I mean, it's still working, it's still warning, but I'd like to actually fix all of the warnings as much as possible. Right, I'm trying to fix all of the warnings as much as possible. So we have a string, and this is going to be string.h, right? So this is going to be string.h, and error no will require error no as well. There we go. So we have a global time, but we don't use it. We only initialize it, right? As you can see, we only initialize this entire thing. And apart from that, we have something working. We can try to run the entire thing, and we have a window. Easy. Peasy lemon squeezy. Ah! Okay, so everything's fine. We can try to fill up the buffer with something, I suppose, right? We can try to fill it up with something. But I suppose we need some sort of a function that can accept the pixels. It can accept the pixels and just fill them up with something. So maybe we're gonna have something like fill pixels, right? So here we're gonna accept the pixel 32 pixels, and then maybe we can accept just the size, right? So, and here I'm gonna be doing a very scary, very dangerous and very unsafe C code that caused a lot of buffer overflows back in the days and still causes a lot of buffer overflows. I'm gonna be writing the code like that. So this is gonna be size. Like this, and then so we also have to specify the pixel that we want to fill this thing in, right? And then it's going to be pixels plus plus equal pixel. Boom, easy. All of the Rust developers right now are shaking and crying by looking at this code. Literally, they cannot handle the raw unsafe power of C. Can your Rust do that? I don't think so. It probably violates 69 rules of borrow checker. Oh. Anyway. So what do we have in here? So now this is how we fill the entire thing. So let's do fill pixels, and what we're going to be filling them with. So let's actually fill them right before we create an image. So this is going to be pixels. The size is going to be basically width by height, and what's going to be the color? We're going to fill it with the red color, the color of the communism, comrades. I actually want to put this function like before all of this stuff, so all of this stuff is not visible to this entire thing. So this is going to be static, maybe this thing is also static. Okay, so that's pretty pog, not gonna lie. Alright, so if we try to do make, it does not work well, because pixels better be defined before this entire thing, because it's C. Can your Rust do that? Your Rust doesn't have a strict order of declaration. Disgusting. Anyway, so if I try to run the entire thing, right, so this is going to be metaballs, and boom, red. The color of communism is here. The color of communism. Interestingly enough, I think I don't like this way of doing this stuff, because it doesn't allow me to feel like arbitrary like squares and whatnot, but yeah, we'll see. Maybe that's fine. So in here we're gonna be maybe filling everything up with some sort of a background color. Let's actually define background color. So this is gonna be background. So, and it's gonna be something like 9999AA, right? So I want something bluish, if you know what I'm talking about. So fill pixels, and I'm gonna say this is a background, and then I'm gonna just do something like that. This is disgusting. This is the most disgusting color I've ever seen. Holy shit. It's just so muddy. Okay, can I just do like 9 with 6? Will that work? That's already fucking better. How about 6 with 5? Is it gonna be better? Look at that. Oh, by the way, we have a rainbow mode. Boom. Shit, it doesn't work. But essentially what the rainbow mode does, it looks for color codes and can display them like this, but it doesn't recognize the hex colors. Fuck. Is there any way to actually fix that, I wonder? So the rainbow mode. Well, where's the rainbow mode? Rainbow fart. Checks the keywords of code to play suitable sounds. 193 downloads compared to like million downloads of other things. Inspired from visual... it's a visual story. I'm not even interested then. Okay, so I'm not surprised that such thing as Rainbow Fart is inspired by Visual Studio Code. I'm not even surprised. Trust me. There is no thing in here. I think maybe a rainbow mode is defined somewhere in Alpha, probably. Whatever. So it's too much time to invest. So let's disable the rainbow mode. Okay, so we have the background, some sort of background, and I think we're ready to start doing things, right? I think we're pretty much ready. So maybe we want to define some sort of a foreground, right? Some sort of a foreground. Some sort of a foreground. And what's going to be the foreground? To see the foreground, we need to be able to render the square. Let's do the thing that I wanted to do initially. So initially, I wanted to do what? I wanted to just do maybe size width, size height. Then we're gonna have the stride, right? We're gonna have the stride, and what we're gonna be having in here is pixel 32 the pixel, right? So this is what we're gonna have in here. And I'm gonna be filling everything up by the rows, right? So we're gonna start with the height, right? So this is gonna be the height. And now within that thing, I'm thinking how I'm gonna be doing all of that. So maybe I'm gonna be doing it like this. So size tx 0x less than width plus x, and in here we're gonna have maybe pixels x. And we're going to be filling up all of the pixels, and then we're going to have pixels plus the stride. So that way I can actually fill a particular subregions of the image, right? So I think I even explained this thing on one of the previous stream, like the trick with stride that allows you to like manipulate subregions of the image. I wonder where I actually did that. I don't remember. Does anyone remember in which episode that was? So somebody in the chat should help me with that. Which episode of the Debugging it was? Who remembers? I think it was somewhere. So first of all, it was definitely Wang Tiles, right? So let's take a look. And I think it was the second episode of Wang Tiles, somewhere here. Hello. And we were explaining shit. So I'm looking at the. Probably, I don't remember. Oh, I think I found it. No. Yes, found it. It's somewhere around 45. Yeah, so this is where I was explaining like the stride and padding and stuff like that, and how you can use it to like manipulate sub images and whatnot in a pretty convenient way. So I'm gonna give the link to this thing in the chat, of course, if anyone gives a shit in the chat, because I'm pretty sure people in Twitch don't give a shit. But on YouTube, I do know that people care. So I'm gonna give the link to the YouTube people in the description. So if you're watching this on YouTube, so give it a try. So video where I explained the stride, the image stride magic, right? Around around 4522, right? 4522. So, but it's not 100% like this specific timestamp, right? Because I don't know, but this is roughly where I was doing that, and I was like explaining how to do these things. So this is the stride, so you can store several images and so on and so forth. So I think it was a very interesting discussion. I think it was a very productive even discussion, which is quite rare on Twitch, to be fair. So, all right, so I'm going to put it in here. So for people who are interested in this kind of stuff. All right. So, and yeah, let's see. Hamikovi, metaballs.
Metaballs, what's that? IT sounds like ITS dogs balokes padji.
Why does it sound like that to you? It doesn't really sound like that to me. Thank you so much for 18 months of tier 1 subscription. Thank you, and welcome to our epic metaball, spicy metaball club. Metaballs is this thing, by the way. So this is how they look like, if you are interested. So this is the metaballs, MongoDB. So, and we're trying to generate this thing. It's probably not going to be 3D, right, but I want to try to generate it in 2D. So, yeah. All right. So we have a fill pixels, right? So, and let's do this thing, fill pixels, right? And here what I need to do, I need to actually provide width and height and width, and I fill this entire thing with the background, right? So if I try to run this entire thing, it seems to be working. And now let's imagine that I want to do the same, fill the subregion of the entire canvas, right? Subregion of the entire canvas with a different color. I can use the same, absolutely the same function to do that because of the stride. So yeah, let me see. So I do fill. Where do I do fill? Fill pixels. Fill pixels. Right, so I'm going to put it in here, right? So this is going to be the pixels. The size that I want to actually fill in here is going to be, let's say 100, and the height is going to be also 100. So this is going to be 100 by 100 region, but I'm going to still set the stride to width, right? I'm going to just set it to width. Width, and this one is going to be foreground, and that will technically fill 100 by 100 triangle within the whole canvas, right? And I didn't have to provide the full coordinates of the rectangle, right? I didn't have to provide that. I only had to provide the position where I start filling, the size of the thing I wanted to fill, and then the stride to like how much I have to jump to fill the thing. So, and that actually is very, very powerful. As you can see, it allowed me to put this small rectangle in here. It's the same function that clears up everything, right? I just use it slightly differently. I can position it somewhere in a different place, right? For example, at 200, 200. To do that, I will have to do something like this. So it's going to be something like that. Why am I using floats in here? I don't know. My brain thinks that I'm doing things in OpenGL. That's why I actually use floats in here. But if you want to position it in a different place, you just give the pointer to a different place, right? And then you do it like that, and width has to be actually capitalized. And there we go, it's positioned in a different place. It's the same function that just fills up all of the pixels, but because of the stride, we have a control of what kind of subregion we can use in here. So we can set the pixel. Yeah, exactly. This is precisely what I did, HQEL. And I explained that in the video that I put in the description. I explained that specifically in this video. So again, it's very, very interesting. Around 45 minutes or so, we had a discussion about this entire technique. But keep in mind that this entire technique is actually pretty unsafe. It uses very simple function, right? And since this function is so simple, I would presume that for a compiler, it would be super easy to optimize, but it doesn't do any sufficient boundary checks, right? That's quite important to remember. So this thing, I would even mark it as unsafe, right? Rust people, look. This is unsafe function. But since it's so simple, I think it could be very, very fast potentially. I think we need to at some point look at the assembly that is generated by this function, and I think it could be maybe something with CMD. Maybe we can look at it right now, I don't know. So, and all of the boundary checks, I think, has to be made in a higher order function. So you need to create a higher order function that accepts actual rectangles and just checks the boundaries and stuff like that, clamps everything properly, and then calls to this function, right? So I think that's how it has to be done. So you see what I'm talking about? So, alrighty. Wouldn't memcopy be faster? Faster than what? This is the first question. And the second question, what are we copying? We're not copying anything, we're filling up the memory. Okay, so let's continue. What I want to check what the assembly will be generated. So let's actually go ahead and take a look at the assembly. So we have that. Let's actually mark it as unsafe, just in case. All right, looks cool. And let me do obj dump, disassembly, metaballs, and let's see. Right, so this is going to be fill, pixels unsafe, and what do we have generated in here? So this is very unoptimized code, I suppose. It just jumps around and it doesn't, yeah, it's actually pretty straightforward. It doesn't even do anything, but it does shift left, which is kind of interesting. All right, so it's a very, very straightforward code. So let me now enable the optimizations and see how compiler would be even able to optimize this kind of thing. And let me see. So this is gonna be unsafe. Oh shit! I marked it as static, so it actually eliminated it completely. So let's actually make it not static, right? So let's make it not static and recompile the entire thing. And let's take a look at what we got. Let's take a look at what we got, and this one has to be unsafe. So, ooh. So yeah, it uses CMD instructions already. Look at that. Yeah. Is it really CMD instruction? At least it's using the XMM register, so I would presume maybe it just copies things in chunks because of that. But this one actually looks very, really interesting. So what is this instruction? If I do it, shuffle packed. Yeah, okay. So it's actually basically using CMD. Yeah. So it managed to optimize it with CMD and shit, which is pretty cool. So yep. Which disassembler do you use? I use obj dump, the best disassembler in the world. That's the disassembler I'm using. Specifically obj dump -d. Right, so that's the disassembler. All right. So the thing I want you to see is just basically how easy or difficult it is for the compiler to optimize this code to something like good that uses CMD instructions. And I think it does the thing. So yes, kawaii freaking this. Okay, so what I want to do now, I want to just go ahead and maybe be able to render a particular circle, right? So the question is how I'm going to be rendering all that. Do I want to just render everything like pixel by pixel? Maybe that's what I want to do. I don't know. All right, so before I go and start the actual work, right, so we only had the preparation. We prepared the canvas on which we're going to be rendering. So, and now we're about to render the balls themselves. Before I go ahead and do that, I want to make a small break because I want to make a cup of tea, right? So, all right, let's continue. So, what I want you to do, let's actually write the function that just renders the actual thing, right? That does the actual work, so to speak, right? So let's put it this way. I don't know, how can we call that? We can call it, okay, let's just call it render scene, right? So we're rendering the scene, so it's gonna be pixel 32. We accept the pixels, and then the size, width, and height, right? So we're gonna accept like the whole thing for now, I suppose. Unless we want to render like subregions, but I'm not sure. Not sure how fine is it gonna be. Yeah, I think. Yeah, in that case, we also then want to have some sort of a stride, right? So that's another thing that we want to have. I think it does make sense. Though, We're gonna heavily depend on X and Y. That's the problem in here. We're heavily dependent on X and Y. So I suppose one of the things that we're gonna accept here as well is the... let's not think about that right now. So let's just try to render the whole scene and see how it goes. Right, we're gonna be iterating, you know, y less than height, plus y, then for size t, x less than width, plus x. Right, and we need to decide where we're gonna have our first ball, right? So where the first ball is gonna be located. So, so this is gonna be something like int ball 1x, right? So, and maybe ball 1y. So what's interesting is that I'm starting to do a lot of like a vector arithmetics, and maybe it's a good time to bring in my LA library that I've been developing for quite some time already. So it's a basically library that has pre-generated vector operations, right? So it has pre-generated vector types, different structures, and some different vector operations on those like types and sizes. So it supports sizes from 2 to 4, and it supports integers and floats and doubles. So all of that is procedurally generated, right? So, and you can find this thing in here if you're interested, and in the description I'm gonna also put this entire thing. So my linear algebra library, there we go. So, and I'm gonna just basically copy paste this entire stuff into my code, right? That's what we're gonna have in here. So I'm gonna take the raw library. So, and let me see. So I'm gonna include this entire stuff. So I'm including la.h, right? So I'm gonna also define la implementation. There we go. And here I can just define vector 2i ball 1, right? So, and the ball 1 is going to be located at, I'm not even sure where we want to locate this entire thing. So maybe we're going to locate it at 100, 100. So for now, we're going to be doing all of that in integer arithmetics. So, but then later we can switch to maybe floating point as well. So ball 1 radius, and the radius is going to be like around 100. Alright, so again, we're generating everything pixel by pixel. It's going to be probably inefficient considering the amount of pixels that we have. So it's just like, yeah, it's a relatively big resolution, so it's probably going to be very slow. And definitely not going to be 60 FPS, but maybe we can, you know, parallelize the entire thing. So I'm going to do the following stuff, and we can now do the thing. So vector 2 position, and the position is going to be vector 2 x and y, right? And we want to take the distance between those two things. So actually the difference, so this is going to be ball 1p, right? Ball 1p, and then we want to take the square length of this entire thing. So this is basically the square length. And if the square length, right, if the square length less than the, I suppose the, how to say that, the square of the radius, right, the square of the radius, right, so something like that. Actually, it could be also equal. We're going to be setting to the current pixel the foreground color, right, so it's going to be x and y. Y is going to be basically width plus x, and so what's going to be the color, I suppose? I suppose we can just say that it's going to be the color, right? So it's going to be pixel 32, the color. There we go. So that's the whole thing that we're trying to render in here, right? So, and then I'm going to take the render scene, right? And then fill pixels, unsafe, then we render the scene. So I provide the pixels, we provide the width, we provide the height, and the color is going to be the foreground color. So that will render just a single circle, right? So that's basically what we'll do. It will render a single circle. This is not really what I wanted to do, but there we go. So yeah, something went wrong. Too many arguments for v2ii. Oh yeah, so it has to be something like this then. What's the next thing? Height. So it doesn't like that the, yeah, it doesn't like that this thing is unsigned, like signed versus unsigned. I think I can probably convert it to size t, like so. All right, and what else do we have in here? So this is the width, and we have a global time. Okay, so let's try to run the entire thing, and we've got the ball. Cool. So I don't like that the contrast between the background and the ball is so low, right? So maybe one of the things I would like to have is probably, I don't know, increase the contrast. How do you increase the contrast? Maybe you actually make it slightly more saturated. So if I do something like that, will it be more saturated? I actually want to do something like this. There we go. It still looks out of place, you know? You see what I'm talking about? It's kind of weird. So what if I do something like this? Okay, so maybe that's a little bit better. Maybe that's a little bit better. Okay, go. So let's see, we can now try to position this entire thing in different places, right? So for instance, if I say it's 200, it's gonna be like that, right? So it just goes in different places. Cool. So what if I want to have the second ball, right? So let me see. So we're gonna have v2i ball 2, and the second ball is gonna be maybe located somewhere in 500, maybe 600, 600, 100, right? Like this. So, and it's gonna have a different radius. So it's gonna be ball 2, and the radius is gonna be, let's say, 75. So, and in here, we're gonna just simply replace ball 2, and this one is also gonna be ball 2. Okay, replace ball 1, ball 2, boom. And if I try to run this and that, so now we have two balls that are pretty close to each other, right? So they're relatively close to each other. That's pretty cool. I still don't like the colors. So what if I change the color to something like yellowish maybe? So what is the yellow? I think it's a red and green. So if I put something like this, that looks way better actually. So it's like a, you know, blue and yellow, they're complementary colors. So they look great with each other. So what if we have the same saturation and like value? So if I replace E with A and 2 with 5, right? So it's basically going to be the same, but just, you know, so what's wrong with you? Oh yeah, it's actually alright. Foreground. Okay. Looks like shit, thank you very much. So I think I'm gonna opt back to what we had. I think it was fine. Yeah, I think it's a little bit better. I think it's a tiny bit better. So I really don't like how I can't just press Q to quit the application. So I really want to fix that somehow. So let's go ahead and try to do that. As far as I know, to be able to handle the key, we have to say something like, let's take a look at this thing. Xsleep manual. Xsleep manual, where is Xsleep? Oh my god. Do I have a local copy of Xsleep manual? Documents. I think I need to have a local copy of the Xsleep manual. So this website, is it even? Yeah, it doesn't allow me to connect. So, but maybe we can download the PDF. Let's just download PDF. I think that's a good idea. So what do we get? I don't know what's up with the encryption. Probably Roskomnadzor is trying to spy on me or something. So the classical shit. Mu PDF, Xsleep PDF. Let's actually open this entire thing and let's find X select input. I think that's the function I'm looking for. Yeah, X select input, and in here it accepts the event mask. Right, so basically you have to say what kind of events you want to handle. And you want to handle key press mask. Right, there we go. And that will enable you to handle a key presses like this, right? So now you are able to handle that, and we can now say pressed key with code this, and it's located somewhere in event x key code, right? There we go. So if I try to compile the entire thing, and as you can see, I'm pressing the keys and it's detecting that I pressed the keys. Cool. So the next thing we need to do, we need to translate, I think, the key code to ASCII symbol, to something like more human readable. I think it's something like X lookup key symbol. X lookup key. Yeah, it's that one. Keys. Yeah, I almost got it. Yeah. So it accepts the event and it gives you key symbol. Oh, this is actually pretty cool. Yeah, it's a key event and index, and key symbol could be like Q or something. So let's actually see what we can do in here. So X lookup key symbol. I provide the event. I think I provide the pointer to the event, right? So I provide the pointer, and the index has to be 0. I don't remember what index means, but it has to be 0 for it to work properly. So, and then if we have Q, I want to just say that quit is going to be true, and then we're going to break. And by default, we're not going to be doing anything. This is horrible, by the way. What the fuck? I guess that's fine. Alright. And now it works. Okay, cool. So passing argument 1 of incompatible pointer, it wants the key event. Okay, so I can do something like this now. Okay, perfect. So now I can just start the application and press Q and it automatically exits. That's precisely what I wanted to do. That is precisely what I wanted to do. Isn't it pogue, fellow kids? I think that's pretty pogue. So the thing about metaballs, as far as I know, they exhibit a very simple property, right? Hopefully I stalled enough to actually weed out all of the clowns from the chat, and now we are able to finally do the actual work. So the metaballs basically have a function, right? So it accepts the coordinates, right? And this function, if I understand correctly, can be just pretty much anything, right? It can be pretty much anything, and it has a particular threshold, right? It has a particular threshold. So usually threshold is this thing, right? It's so what is x and y? For 3 dimensions, it defines yeah. So x and y is a position in the dimension, and x0 and some other stuff is essentially the center of the ball, right? So they are suggesting to use inverse square root. But I'm wondering if we could just use the distance, right? Can we just use the distance and use that as a threshold? That would be actually kind of interesting, just to see what kind of shit will be generated. So yeah, let's actually see. I think that's gonna be interesting because they word it in a very like generic way. So it's some function, right? So it's some function, but people usually use that one. What if we don't use that one? Right, so who knows, maybe we can come up with more interesting results. So, oh shit, and in here we're actually starting to do, so if we're gonna use the distance, well, technically, so we can use like a square root. That's the distance, really? Is really? Looks more like an inverse of a distance, you know. So maybe that's the distance, but inverse, it's an inverse of a distance. Anyway, so so this is going to be this thing, and we can do the rest of the stuff. Swear to God, people. Okay, so here's the first one. And what do I want the distance to be? What's going to be the threshold? The threshold could be maybe... What if it's going to be the sum of these two things? Well, it's going to end up being simply the two circles, I suppose, right? So it's not that different if I do something like this. Right. This is the sum. We can put the sum in here, right? So this is the sum, and it's less than the ball 1 radius plus ball 2 radius. I think it's going to end up being the same, right? It's going to end up pretty much being the same. Pixels, y multiplied by width plus x is going to be the color that we're trying to set in here, right? And if I try to, well, I mean, I have to do it like this. It doesn't even draw anything. I wonder why though. Right, if the... Oh, maybe this is because they're not close enough? What if I say something like 100? Probably the sum... Oh, the sum is probably very, very huge, right? So, yeah, so I probably have to take something like square and then square of this thing, right? So, and it doesn't really draw anything. So, what could be the threshold? Let me try. I just want to see what's usually the threshold in here. So, how big it is usually. So, because I'm really curious. Okay, so it's, well, that's pretty huge, right? So, and it's probably at 0, 0, right? It is at 0, 0. So I wonder if at some point it can become a bit smaller, right? Can it become a little, like 1,000? But I mean, well, that was a mistake. Okay. Alright, let's go ahead and code the formula from Wikipedia directly. I was thinking that maybe we can come up with something more interesting, but whatever. Let's just code the formula from Wikipedia directly. So for that, I'm going to be using the floating point stuff, right? So this is going to be that. Right, so this is going to be the F. It's going to be that. Cool. So this is also going to be F. This is F. And so yeah, since we're starting to compute like pixel stuff on a level of a pixel stuff, maybe we can do some sort of like a sub-pixel math as well, and we can simply add half of a pixel, v2ff. So then we compute the distances between the center of the pixel, right? So it's going to be between the center of the pixel. So if we replace v2i, v2f, there we go. So here is the square length. To be fair, since I'm using floats, I should be able to just use length, right? So this is going to be the length. That gives me the length, and then I'm going to do over this entire thing, right? And if it's less than a particular threshold, right? I wonder what's going to be the threshold. We can try 1,000, or maybe we can try ball 1r plus ball 2r and just see what's going to happen. Is it going to produce an interesting results? Well, it just produced everything in here. So maybe because this entire thing is too big. So the question is, what should be the threshold? Can I make the threshold like very, very small now? And no matter how small I make this entire threshold, it still colors everything blue. So the question is, what the hell is wrong in here? So it has to be less than a particular threshold. The simplest fall-off curve that satisfies this criteria is where is the error distance point, this formula. Okay, so where did I make a mistake? Does anyone see a mistake in here? Does anyone see anything? Because it doesn't really look like there's too much of anything. So here's that, and then we compute. We take the distance between ball 1, so the center of a particular ball, to the current point, right? And we compute the length of this entire thing. Well, oh yeah, I see. What I have to do, in fact, I have to do it like that. I surely hope somebody in the chat actually caught this mistake. Right, so that's what you have to do. It's not the same as like putting them under the same like fraction or whatever, right? So it's definitely not the same. So I wonder if I can just put 10 in here, and it still doesn't work. That's really strange. No matter what I do... Oh, because it's not a float. Are you surely somebody in the chat caught that as well? Okay, so what else do we have in here? So ys is always smaller. What's the usual threshold of s? That's really strange. So we can try to exit like this. Right, so oh, it's usually very small. Look at that. It is actually very small. If it's less, usually if it's less than equal. We can try to save that if it's less than 001. I think that's a pretty good threshold, if you know what I'm talking about. Right, so because I didn't know what kind of values to expect in here, right? You know what I'm talking about? Now we're talking, look at that. So that's a spicy metaballs. It's pretty cool. Yeah, that's pretty cool. I just didn't know that, but it's kind of, the colors are kind of inverted, right? So, which is strange. Maybe we have to do it the other way. Yeah, we had to do it the other way. So if it's bigger than a particular thing, that means we have to do that. And I wonder if we can animate that. Right, so we have ball 1, but what if we don't even have a like a radius or whatnot, right? So it doesn't really matter that much. So if we animate vector 2 ball 2, right? So, and this is where we're gonna put all this entire thing. So, and when we're rendering the scene, right? We render the scene. I'm gonna put this thing like this: vector 2 ball, vector 2 ff. Actually, it's gonna be single one, 400, 600. Right. So maybe we're gonna animate the x of this entire thing, right? So that would make sense probably. So I'm just thinking, what's the easiest way to handle that? What's the easiest way to handle? So maybe the render scene is going to accept both the background and foreground. So this is the foreground, right? And we're gonna accept pixel 32 background as well, right? And we're gonna simultaneously fill everything, right? So if this is the thing, we use foreground, right? So this is the foreground. Otherwise, we use the background. There we go. So that's the way it's going to go. And that way we don't really need to feel unsafe, right? So we can just always render this entire thing. And that way we can always render this thing in here, hopefully. I don't know how slow the entire thing is. We can actually try to measure that. Okay, before trying to animate this thing, let's see how slow the entire process is, right? Because who knows? Maybe it's so slow you won't be able to animate that ever. You know what I'm talking about? You know what I'm talking about? So this is the foreground, this is the background, this is the ball, ballsy ball, and render scene, semicolon, and there we go. So we have that shit. And maybe I can put it here. Okay, so I probably should put them apart a little bit. Can I just put it like this? Yeah, so they're also kind of like attracting to each other. You see, this is actually looks a little better. They're sort of attracting to each other. So that's cool. And what I want you to do, I want you to measure the time, how much time it took to actually render a single frame, right? So render scene. I'm gonna just grab the current time. Right, so we're grabbing the current time, and then I'm going to be rendering that time. So I also need to get begin, I suppose. Right, so I'm gonna take the begin. You know what, maybe I'm gonna just steal the profiler from Wank Tiles, because Wank Tiles has a pretty cool profiler. And maybe I can just steal the code from there. That would be kind of pow, if you know what I'm talking about. Let's just go ahead and steal that shit. I think that's gonna be cool. I think that's gonna be cool. So, let me see. So, Wank Tiles, SRC, here's the profiler. And I'm gonna copy paste that thing here, and I'm gonna be including the C file, prof.c. There we go. So that way I don't have to think too much, right? Because the profiler is really cool. What you do is that you begin clock frame, and then you end clock. And I think the last thing you do, you dump the summary, right? You dump the summary, and yep, so you'll get the timings right away. Okay, so that didn't really work as I would expect it to work, which is kind of weird. So let me take a look at the profile. So dump summary. Oh yeah, okay, so dump summary is supposed to... Oh, you also have to define the profiler. Alright, so by default it's just like not gonna work unless you actually define the profiling. Okay. So, and in here you have to provide the std out, of course. There we go. So it took... Ooh... Well, it was relatively fast, 21 milliseconds. So this is definitely not 60 FPS. You know what I'm talking about, chat? Because for 60 FPS, if you take like 1 over 60, it has to be at max 16 milliseconds. But here we have 21, so that's already not really good. It's already no bueno, in my opinion. One thing we can try to do to combat that is maybe reduce the resolution. The reason why it's so slow is because we're using very dumb method, right? So what we can do in here, maybe... so effectively this entire thing is basically 16 by 19 multiplied by 100, right? So we can try to preserve the ratio, but keep it like half of that. You know what I'm talking about? Just keep it half of that, and maybe that will be a little bit faster. Now we're talking, this is already a little bit faster and can probably fit into the 60 FPS, right? So now we're freaking talking. So exit 1, so begin clock, where is the begin clock? There we go. So let's get rid of the exit and let's see the resolution. Okay, so it's a very relatively small resolution. That means we'll have to probably make the balls a bit smaller and not place them so much far apart. So this one is gonna be since we're dividing everything by half, we might as well just do something like this. So we can divide the positions in half, and also this kind of thing in half, right? And maybe also this kind of thing in half, just to make it, to keep it easier for us to work with. So maybe that will place it. Interestingly enough, that produced a very strange code, a very strange situation. Maybe I have to multiply it by 2 then? Okay, so now we're talking. Alright, that's cool, that's cool. So this is more manageable. This is more manageable. So we can probably multi-thread at some point. I just don't want to go into the business of multi-threading without having something like some sort of animation. You know what I'm talking about? So, yep. Yep. Okay, that's pretty cool. So what I'm thinking is that maybe we're also gonna accept the second ball as the parameter, because maybe we want to animate both of them. Right, I think that's a cool idea. So here's the ball 2, this is the ball 1, this is ball 1, ball 2. So we're just doing this kind of thing. Cool. Alright, I think we're ready to animate this shit. I think we're kind of ready. So here's the ball 1, ball 2, and we also need to keep track of the velocity of the balls. So it's going to be vel1. So this thing is going to be like around maybe 100 and 200. I don't know, if we're gonna be doing that each frame, maybe those values have to be small. Right, maybe those values have to be small. Oh, you know what? We're actually keeping track of the time, right? We're technically keeping track of the time, so we can actually tie the position of the balls to the time, right? And don't worry about, you know, keeping track of the velocity, the current state, and so on and so forth. All right, so that could be very much interesting to do. So ball 1, I'm gonna place ball 1 somewhere here. Then I'm gonna grab this entire thing, and right before put image, this is gonna be 1. The second one is gonna be effectively, we probably want to generate like a sine wave thingy, right? We want to generate a sine wave based on the global time, right? So this is going to be parameter t sinth of the global time, right? That gives us the actually, what does it give us? It gives us only the x, right? So that means it's actually y, so it has to be cosine and then sine f of global time, right? So this is going to be that. So that give us the direction vector, right? So that's the direction vector, and I might as well actually call it d, and it's a v2f, something like that, and that's the direction vector from the 0, and it just like rotates around as the time goes by, right? Just rotates around as the time goes by. So then we need to find the center of the screen. The center of the screen is relatively straightforward. We do something like 2f, width and height, right? And we want to actually divide all of that by 2 to find the center. So we can simply multiply it by 2ff, 0.5, vector 2f multiply. There we go. So that's the center. That's effectively the center. So then we want to add, right? We want to add the center, these things, but multiplied by a particular magnitude, right? So what we're gonna multiply it with? What we want to multiply it with? We want to multiply it by, oh boy, so the length of this entire thing. The length could be around maybe half of the height, right? So something like half of the height, and this thing has to be back to ff. Right, there we go. Membrilla Amarilla, thank you so much for 7 months.
Mr. Tsuding Chat Tsudin Sleep.
Thank you so much for 7 months of tier 1 subscription. Thank you, thank you, thank you. And welcome to our epic metaball club. All right, so here we have a center. Here we have a vector that rotates over time, right? And we extend that vector to the half of the height, right? And then we add those things together, creating the position that revolves around the center of the screen. That's basically what's going on in here. So, and that's going to be the ball 2, right? Vector 2f, ball 2. There we go. This is how we do all of these computations, and maybe that one is going to be ball 1. Right, so vector 2, ball 1, so I'm going to place it in here, and this is the ball 2. There we go. So this is basically like a vector computations and whatnot. Simply vector computations. All right, let's see if it's gonna work. And it's based all on time, so we don't have to keep track of anything. Hopefully that will produce an interesting result. Doesn't even compile properly because we have a lot of garbage in here that is not important. We can remove all of that garbage. And what else do we have in here? So I suppose if I go to comma, and there we... Oh, shit! Look at how smooth this motherfucker is! Oh, fuck! This is not OpenGL, by the way. This is not even OpenGL, that's how cool it is. Holy shit, I really like that. My god. Oh, wow. We have only 30, yeah, it's only 30 FPS, but we can try to speed that up, or like do something about that. This is extremely satisfying. I didn't expect that to be so satisfying. What the fuck? That's so cool. We're not even, oh well, we actually do an optimization like 03 and shit like that. So I wonder if we can make it a little bit faster by using like Clang, because Clang applies even more optimization than this. Right, so maybe that will make it faster. We're not even synchronizing anything, but yeah, that's very cool. So maybe we can tie some of these like things to let's say a mouse. Right, so okay, we're animating the ball, but what if the ball, the center of one of the balls is going to be related to a mouse? And I also instantly got another idea. Okay. So make the position of the second ball equal to the position of the mouse. Right, so this is one of the to-dos I wanted to have. Another to-do I want to try, what if the balls had different colors? You know what I'm talking about? What if they had different colors and then we would blend those colors? Based on what, though? I guess we could blend those colors based on how close you are to a certain... it's kind of, yeah. How would you do that? How would you do that? That's a very interesting question. HSL of the distance, maybe, I don't know. Maybe we could just... I'm thinking about just blending things together. But this one is hard because I don't fully understand how this formula works. So it's an inverse square root of the distance. Wait a second. Inverse square root. Okay, so for that we'll have to do sqrlen, and okay, wait a second. Before I go into that, let's measure the current performance of the frame. Let's measure the current performance of the frame. One more time. One more time. So begin clock. Frame. Right, so the end clock, we don't have to prove anything, and then dump summary to std out, and then we're gonna instantly exit because we just measured this entire thing, we don't really care. Right, so that's the performance of the frame right now. Right, that's the performance of the frame. So it's a 5 milliseconds. Right, so it's around 5 milliseconds, which is fine. Can we get it down by using the legendary square root, inverse square root? We're using the legendary inverse square root. Let's see. So, and this is going to be just a square length. QR SQRT. I wonder if it's going to be faster. QR SQRT. Maybe not. And let's see if it's going to be... It is faster. Holy shit, it is actually faster. Well, I mean, it was like 5, now it's around like 3 or something. But the question is, does it produce the same result? That's the most important thing in here. Does it produce the same result? So I'm gonna disable the profiling, right? So, and let's see what's gonna happen. Well, it does produce... Holy, it does in fact produce the same result. The legendary inverse square root actually works. Everybody's talking about like the legendary inverse square root, but has anyone actually tried it in production? Right. Matthews F777, thank you so much for...
32 metaball студентпок.
Oh my god, 32 months of tier 1 subscription, holy shit. Thank you so much, that's pretty powerful. Alright, that's pretty cool. But the question is, can it actually speed up the full resolution, right? Remember how like I didn't want to do the full resolution because it's actually very slow. Can we actually do that? So let me do the following thing. If defined fast rsqrt, right? So we're gonna use that. Otherwise, we're gonna use the slow version, right? So this is gonna be sqrtf, and might as well just do like this, right? It's a very slow version. Fast square root. Fast square root. Okay, so I'm gonna enable the profiling, and if dev prof, we're only gonna exit if the profiling actually enabled. Yeah. So the profiling enable, we're gonna measure the one frame and we're gonna instantly exit. If the profiling is not enabling, we're not exiting, allowing the entire thing to actually render properly. Okay, so the profiling is, it exited abnormally because, yeah, I see. Okay, so it's down to 5-6 milliseconds, right? It's down to 5-6 milliseconds. Now I'm gonna go and increase the resolution to its original size, right? So it's like a full HD, and as you can see, it's actually around like 15 milliseconds, not allowing us to run this entire thing in 60 FPS, right? So now I'm going ahead and enabling fast square root, and let's see how quicker the entire thing will become. And it fucking fits into 60 FPS. Foo! Oh my god, Cormac! Thank you so much. Who actually invented that? The algorithm was originally John Cormac. Thank you so much. Your algorithm actually allows me to run this shit in 60 FPS. Something that I didn't expect that I will be able to do on the stream, but yeah, so I just stole the code from you know, what the game was that? Like a Quake or something? I don't know, I don't play video games, I'm sorry. But yeah, that's actually pretty cool. Okay, so let's actually disable profiling and see if it's going to actually be fast enough. It is fast enough. It's a little bit choppy, not gonna lie, but it's computing relatively well, so we can kind of run it in 60 FPS. There's a couple of things that you can do in X11, I suppose, to make things go a little bit faster. But I don't think it's gonna help. So one of the things you can do, you can export not into the window, but into the like a back buffer pix map, right? And then you can bleed the back buffer pix map via xcopy area. There's a special function and basically bleeds the content of the back buffer into the window. But I would argue that it's not gonna make things faster in our case, because we're rendering into an array of pixels, and we still need to send that array of pixels over the X11 wire. The problem actually comes from the fact that X has a client-server architecture, right? So if you use Linux or Unix a little bit, you know that X11 has like this client-server architecture. Alright, so that means the server is the program that is responsible for displaying everything, and client is your application that connects to the X server. It connects to the X display and issues command to display things around, right? So you have X11 server. So actually, can I, yeah, server that operates the display, right? So then you have a display somewhere here, and it basically shows everything on the display, and your app client connects to the X server to display things on the display. So the reason why it is like that is because it comes from a very old times when you had mainframes like and big computers, and everyone was using those big computers So I suppose in that case you would be running the server and the mainframe was like application on the mainframe would be connecting to you and stuff like that. But the point is these two things can be on different machines, right? So these things can be on different machines, but usually they are on a single machine. And even on a single machine, they have to use some, you know, sequential inter-process communication mechanisms like sockets or files and stuff like that. And if I want to do export image, right, export image, I'll have to send all of the pixels over that wire every single frame. That's why it's so choppy, that's why it's so slow, because every frame I have to send a lot of pixels from the client to the server all the time. And having like a big smack back buffer, I think is not going to make it faster, because I'll still need to send those pixels just to a different destination, right? But it's still over the wire anyway, so it doesn't make any sense. But there are workarounds for these kind of problems. Who knows the workaround to make this kind of thing faster? Who knows the workaround to not send the image over the X11 wire all the time? Yes! The lucky winner said the magical 6 letters in the chat. MIT SHM, yes. MIT SHM. So basically, this is extension for X11 protocol that basically says, fuck X11 wire. We're gonna send all of the information over the shared memory. So, and shared memory is basically like a chunk of memory that two processes on the same machine can map to their address space, and they can modify these two addresses and they can see each other modifications. Right, and basically you can put your image, X image, into shared memory and tell X11, okay, take that image from the shared memory, and X11 will map that chunk of memory and will take it directly, bypassing the wire bullshit. So basically, if X server and X client are on the same machine, they can just map the same memory and communicate directly over the same memory, making this entire process like way faster. I already used MIT SHM extension, and it's hella fast. Like, holy shit, it is extremely fucking fast, to the point that you can actually do real-time like rendering over that thing. And it's just like, it's amazing. So one of the things I would like to try to do, maybe put the like our pixels buffer into shared memory, and instead of like export image, use this extension, but I don't know how much time it will take, and maybe that will make the entire process even faster. Because we already can render at 60 FPS, it's just like X11 is incapable of taking this shit at 60 FPS unless we're using MIT SHM extension. Right, so that would be interesting to try to do at some point. What do you guys think? And also this entire process may become even slower as we add more and more balls. Also, balls actually are not placed in the right places, so I think I want to do something like this. So just a second, copy area. This is the window, so okay, so that's a little bit, maybe I want to actually make this thing revolve a bit faster, so I'm gonna multiply the global time by 2. Oh shit. I think that was a mistake. Okay, that definitely, well, I mean, I didn't multiply both of them, I suppose, that's why it was a mistake. Yep. And maybe the radius is going to be actually like a 25, and maybe the entire thing is going to be like 4. We didn't mess over all of the pixels, yes. Alright, so I think I want to make a small break. Super quick, just a second. Okay, so yeah, let's make a small break. Alright, so let's continue working on this entire thing. So we have a couple of things to like left to do. For instance, make the position second. So what was the another one? Second ball equal to the position of the mouse. And I didn't create the to-do for blending the colors, right? So let's actually do something like this. Blend the colors of two balls. So that's another thing I would like to do. And the third thing I would like to do is to send the image over MIT SHM. I have no idea if we'll have time to do all of these things already. Probably not. We'll see. But I think MIT SHM is not that important, in my opinion, right? It will be kind of cool, but it's not that important. So I think the easiest thing to do right now would be to actually handle the mouse, right? So do we have something like mouse? I forgot this. It's something like mouse motion. So X11 doesn't allow you quite easily to like find all of these things, right? Mouse motion, is that a thing that you have? No. Mouse move. Okay, so maybe I'm gonna do the following thing. I'm gonna try to find this stuff somewhere here. It's gonna be grep key press mask. I want to find the place where all of these things are defined, right? And we must have something like pointer motion mask. Is that a pointer? Mouse. Okay, so it must be pointer motion mask. So, all right. Pointer motion, right. Event mask, pointer motion event wanted hints. So they probably not even mentioned the mouse because this entire system is so old. The mouse probably didn't even exist back then. Right, so a keyboard and one pointer, usually a mouse. Okay, so that's basically what it is. It's a pointer motion mask. Okay, so let's go to here and say that's one of the things we want to be able to handle. Right, and I presume the type of event that you're gonna have is basically pointer motion. By the analogy with key press and key press mask, I would assume that the type is going to be pointer motion, but who knows, it could be anything, literally. And pointer motion. All right, so let's try to do this entire thing. I'm going to recompile the entire stuff. Metaball. It's a spicy metaball. So the reference and typed, well, you didn't really care before, or maybe, yeah, it's completely different. So, yep. So the same analogy doesn't really work here. So yeah, it is what it is. Or maybe I made a typo. I don't think I actually made a typo, so I will have to do something about that. So maybe I could do the same trick where I could go to user include X11 and just grep specifically for this thing and find the place where all of these things are defined. Yeah, here's the key press. And in here, we can have something like, okay, so motion notify, of course. So the mask to handle key presses is a key press mask, and that allows you to handle key press events. But if you have a pointer motion event, you have to use pointer motion mask, and that probably corresponds to motion notify. Of course, that's a very consistent and very intuitive naming scheme. That is very, very cool. I really appreciate that. Anyways, so motion notify, right? So it's probably that's what it is. Maybe it's something else. But I think that's the only thing in here, right? Motion. Yeah, that's the only thing that related to motion. Oh boy. So this is going to be the main, and this is going to be motion notify. Motion notify. Okay. So, and if I try to do the entire thing like this, it's going to be minus B, and then metaball, and there we go. Can you see that? So it handles the motion notify. That's cool. So the next thing we need to do, we need to actually grab the coordinates of this shit somehow. And I wonder how we can do that. We can probably basically put a debugger in there. Right, so 135. Yeah, maybe I can do something like this. So let's do break. And then I'm gonna run and okay. And then if we take a look at the event, right, there's a lot of shit in the event, right? So do we have, yeah, motion? It's a X motion. Okay, so if I print event X motion, what kind of shit do we have? We have X and Y, which is kind of cool. So right, let's actually try to use them. Right, so let's try to use them. This one is going to be event X motion X, event X motion Y. There we go, there we go. So I'm gonna actually quit this entire thing, and now if I try to rebuild the entire stuff, something broke completely. Like, what the fuck? Wait, what? Where are the balls? Is that because... Ah, I know where... Well, I don't know where. Does anyone know what the fuck is going on? Balls are gone! Where are the balls? I don't see the balls. Where is the ballsy balls? Did I make some sort of a mistake in here that it doesn't display them anymore? Or what did I do? Did anyone notice what I did? I did probably some small things. Some small thing. And I'm not even sure what the fuck is going on. Why don't we see the balls? Huh. That's really, really strange. So they're rejecting QRS. I don't think so, actually. I mean, we can do fast. Okay, so I think apparently I fucked up the QSQRT accidentally. I wonder how. Okay, that's really strange. Fast inverse square root. Did I accidentally remove something from this piece of code? I could have actually accidentally removed something from it. It could be that, but I'm not sure. So here's the new, and yeah, it doesn't work anymore apparently. So that's actually really strange, right? So if we're not using the fast inverse square root, though it's still working fine, relatively fine. So, and if I enable the profiling, right? Yeah, it's rather slow, but it's still really, really strange. But it used to work. Like, what did we do to make it stop working? I don't know. So maybe somebody actually in the stream noticed what the fuck has happened, but I don't know what the fuck is going on. Anyways, so we can have a ball 2 somewhere. Right, so this one is going to be something like that. Vector 2f, ball 2. Right, so, and initially it's going to be somewhere vector 2f. Has anyone noticed what exactly happened? Like, because you all saw that this thing worked, but now it doesn't work anymore. So does anyone know what the fuck has happened? Maybe I was using that incorrectly or something. Okay. So vector 2f, and it's going to be ball 2. Right, so, and now, if we are not using fast square root, that should be fine. So what do we have in here? Too few arguments. Okay, so it has to be ff. All right. So that's pretty cool. You see, you can now control that with the mouse and shit. So that's pretty cool. Look, look, look. Mwah. 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 Okay, so yep. So we can now play with this kind of thing. The problem also is that they have to be the same sort of size now, if you know what I'm talking about. Right, so I wonder if I can make them a little bit bigger by making it like this. Actually, the bigger I make that value, the smaller they become, so maybe I have to do something like this. Oh yeah, that's a huge bold. Okay. This is really fucking satisfying. Oh my god, holy fucking shit. I wish you could try that for yourself, but I'm not gonna upload that to GitHub. I'm not gonna give you the satisfaction of trying to do this thing. Look at that. Oh shit, that is so cool. So cool. We probably need more metaballs. Cool. So what else are we going to have? The question is like, how can we even blend these things together? Also, to do fast RSQRT stopped working for some reason. I have no idea why. Because I didn't see any reason why it would stop working. Okay, cool. What else do we have in here? Blend the color between the two balls. To blend the colors between the two balls, we probably have to have two different, you know, colors between the balls. So, but we probably have to provide the background somewhere here, right? So this is going to be the background. The second thing is probably going to be the color 1, right? So it's going to be ball 1 color, right? It's a ball 1 color, and this one is a ball 2 color. So that's basically what we have in here. So then we have a background, ball 1 and ball 2. Ball 1 and ball 2. So if we're doing foreground, which of the colors do we use? Which of the colors do we use? We can try the one that is the closest, right? That's the thing we can try. The one that is the closest. Or maybe it could be like different proportions, if you know what I'm talking about. So if it's all about proportions, we can just use the proportions of these components, right? So basically that thing over this sum. Yeah, because that thing like forms a proportion that you can then use to blend two things together. Yes, so that's the thing we can do. Okay, So let's actually split these things up. Right, we may have something like float s1. All right, and essentially this thing is going to be like this. So this is the float s1, and then float s2, right? So this is going to be ball2. Yeah, and this thing stopped working for some reason, for whatever freaking reason, I have no idea. I have no idea why. I have no idea why. So, and then this is going to be in a very similar way, S2 and ball2, right? So, and then float S, S1 plus S2. There we go. So, depending on the, like, whether we enabled fast square root or not, we're going to have this kind of thing. So, and the question is, all right, so this is the foreground. Maybe we could have something like blend pixels. Right, and we're blending from the ball1 color to the ball2 color, but in what proportion? In what proportion? Right, so I suppose we can use the proportion of like S1 divided by S, right, because that's the proportion of the first color. Right. That's basically it. That's the entire thing. So the only thing we need to have in here is the function that blends two pixels together, right? So yep. Let's go ahead and do that. So this is going to be static and accepts returns pixel 32. This one is going to be pixel 32a, pixel 32b, and that one is going to be basically the proportion, the percentage in like in which we want to blend all these things together. So I suppose now we need to basically extract each individual component of the pixel, right? And blend them together, right? So we can have something like, I don't know, pixel 32, a red color, and the red, we know that the pixels we store, the pixels that how X11 accepts them is something like this, RRGGBB. Right, so to extract the red component, we have to shift it by 2 bytes, right, to get to these things. Right, just in case I'm going to actually parenthesize everything appropriately, and then I'm going to take this thing. Right, so we have R, and then we have to do that for the second color as well, right? We're going to do that for the second color as well. So we have the red component of A and the red component of B. So, and the next thing we can do, we might as well actually, you know, convert that to float right away. So we're converting it to float right away, so it's easier to maybe lerp them around, and we're going to be using the lerp function to do all of this stuff, right? So we're going to be lerping from AR to BR with the percentage of P, and that's the new R. That's basically the new R. Cool. So, and we have to repeat that 3 times for each individual component here. So it's going to be probably slower. Well, we're not using very slow operations though, right? So, but it could be slower. So this is going to be G, 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 and the green is located at the byte 1 essentially, right? So then we're going to be doing B. It would be nicer to actually do all of that in integers maybe, but I'm not really in the mood of doing that in integers. And then we want to be converting all of that to, I suppose, pixel right away. Let's actually convert it right away to the pixel. Oh my god, where am I? So it's going to be pixel 32, right? So this is the pixel 32. Pixel 32, pixel 32, right, and now I need to compose everything back, so I need to shift R by 2 bytes, like this, right, then G by a single byte, right, and then B by 0 byte, right. But Zoyan, the compiler will optimize that away. Oh no, it will optimize that away. You're not supposed to do that. It's useless. It's pointless, Zoyan. Oh. All right, so let's see if it compiles or not. So maybe I would like to make some of these things a little bit more explicit, right? So let's make them a little bit more explicit. So this is what we're converting in here, right? To float. And in here we're going to be directly converting lerps to pixel 32. There we go. So now compiler has a little bit more information and our code looks like Lisp. Yes, I absolutely love C typecastings. Right, look at this Lisp code. Absolutely beautiful. Holy shit. Anyways. So let me see, is it gonna compile? Okay, so where is the error? So dereferencing, type pawning, and some other shite. Oh, I see what's going on. I forgot to do the thing in here. Thank you, compiler. Very cool. The compiler actually caught some shite. Okay, so B declared as a different. Really? Ah, fuck. Okay, let's call them NR, NG, and NB. Whatever. I don't really care. So it's like stands for new, right? Why? Yeah. Okay, are you gonna be happy now? Background, so incompatible type for render scene, and that happened. Okay, so that makes sense now. So first we provide this thing, and then we're gonna have a foreground ball, maybe ball 1. Maybe I'm gonna actually get rid of the notion of the foreground. Right, so this is gonna be that thing, and another thing we're gonna have is like magenta, magenta. And we're gonna remove this entire shit. Is it gonna work? Is it gonna work now? Yo! Comma. Boom. Look at that beauty! Holy fucking shit! It is blending. It is mother flipping blending like fucking crazy. Holy shit. All of that on CPU, boys and girls. All of that on a freaking CPU without any shaders, OpenGL, or anything like that. We're rendering that on the CPU on the same machine on which I'm streaming. Look at that temperature of the CPU. It's fucking dying, but yeah, it is rendering pretty quickly. So so it just shows you how fast computers are. But I mean, you probably can do more on the GPU, of course. Yeah, so that's pretty cool. That's pretty pow, not gonna lie. So yeah, we blended shit together. That's pretty cool. Blend the colors. So I still can't believe that this shit does not work. Like, why don't you work? Yeah, it just stopped working. Pointer dereferencing, but that's... Oh, wait a second. Is that because of the optimization? Wait a freaking second. Could it be... And we didn't really switch the compiler, but it could be because of this shit. What if I disable all of the nasty optimization? It works, but look at that speed. Anyway. But now it works, actually. So fast square root works. Fast square root works, but we're incapable of rendering like at all now. Without all of the optimizations and shit like that. So if I disable the fast square root, it's even slower actually. Without the square root, it's even slower. So that's really interesting. Apparently, full optimizations screw up the fast square root. Yeah, they completely screw it up. I wonder why. Strict. Okay, so can we say no strict aliasing? It actually warns us about strict aliasing bullshit. So let's try to say no strict aliasing. Please, Mr. Compiler, no strict aliasing. Can you do that shit for for us. No, we didn't improve anything apparently. Okay. So yeah, that's actually very interesting. We discovered something very, very interesting. So we discovered that, you know, full optimizations actually fuck it up. We can try O2, why not? We can try O2. Okay, so and if I go to O2, still no. How about O1? And in O1 it kind of works, but it stops working at, okay, so yeah. It is what it is, and it isn't. I think it's too much of a magic for it to be optimized properly, unfortunately. It's too much of a magic for it to be optimized properly, but yeah. I wonder if Clang could do that a bit better. Right, so let's actually use Clang for this kind of thing. So Clang works fine, and now I'm gonna enable fast square root. Oh, in Clang it works fine, so we're using fast square root and it's fine. There is probably a bug in GCC. So yes, fast square root doesn't work on GCC specifically. Also, it would be nice to profile them. So let's quickly do that. So the fast square root, it's actually barely on the 60 FPS. It's barely on the 60 FPS, but I would presume that without this fast square root, it's pretty much the same actually. If you look at it, it's well, maybe it's a little bit faster, just a tiny bit faster. Yeah, the fast square root is just a tiny bit faster. Just a tiny bit. What's up, Deep Singularity? Hello, hello. Don't CPUs have a square root instructions? Probably. Maybe that's exactly what they're using. And maybe, by the way, maybe Clang actually optimizing the fast square root to use like the CPU instructions, but yeah. Oh, by the way, you know, there is a problem with the way I blend the colors. My blending is not gamma corrected actually. My blending is completely not gamma corrected, and that's why the gradients are like really pointy. Right, you can see that it's really bright, but then it just jumps into the darker parts. So we can try to gamma correct the blend pixels. Right, super quick. To gamma correct this entire thing, I suppose. So all of the components are actually square rooted. So what we need to do in here, I think, we have to multiply everything, like rise it to a particular thing, to the square. We need to square it. Oh my god. So BG, then AB, BB, right? So, and after we did the linear interpolation between these things, we need to square root it back, which will make the whole process even slower. But maybe now it looks a little bit better, maybe? Does it look better? What do you guys think? It's kind of hard to tell, actually. But it feels a little bit more linear now. Feels a little bit more linear. So yeah, maybe we'll have to do that. Maybe I don't know. So let's just keep it to the original one. I don't know. So this one BG, AB, BB. Right, and then we don't need to do square root at all. We don't need to do square root at all. I think this one kind of looks a bit better, to be fair. I think it kind of looks a bit better. All right, so what other to-dos we have? Yeah, so it stopped working, but now we know that it's not working on GCC. So this breaks on what is the version? I have a pretty old GCC actually, 8.3.0 with 03. Right, so we investigated that problem. It will be interesting to investigate it even further, but I'm not sure if we have enough time to do that. And the last thing we can do in here, we could probably do that over MIT SHM, but our entire thing is not fast enough for 60 FPS anyway, so I'm not sure if it makes any sense here. Right, so it's too slow for 60 FPS. But yeah, that's pretty much everything that I wanted to try out today, right? So do you guys need this application? Do you guys need it? I might actually commit it to like somewhere if you guys want to play with it. Right, to GitHub. Let's actually go ahead and do that. So let's do git init, git ignore. I suppose I'm not gonna ignore metaballs, right? So this is the metaballs, and let's initialize this. Git init. There we go. So we have a bunch of to-dos in here. I'm not sure if I do care about them. So yeah, I think these to-dos are not really relevant. I'm not going to be solving them in the scope of this project anyway, so it doesn't matter. Okay. Ready, set, go. Alright, and I'm gonna outsource, open source that under MIT. And readme is gonna be md metaballs, right? And of course, we probably need to have some sort of a thumbnail, right? So let's quickly do the what. Let's run the metaballs. Metaballs, and they are not really centered well in my opinion, so I think we should make them big enough so without changing their positions. So render scene, to make it bigger we actually have to make this value smaller as far as I know, right? Yeah, boy. Okay, so can I have something like this? And did that create the screenshot? I think. I wonder. Did that create the screenshot? So August 13, here it is, and we've got the, well, I mean, it's actually kind of shit. What if I open this thing in the? Yeah, whatever. Yeah, for some reason it actually created this shit. I don't know why. Is that because yeah, I think I know why. Compilation of our nation. Okay, so that's what I wanted to do. And now that's a pretty juicy thumbnail. Yeah, that's pretty juicy. I really like that. Okay, let's go here, and I'm gonna copy paste it in here, and this is gonna be the thumbnail for all of the stars, to debate all of the stars on the on GitHub thumbnail. There we go. So in an readme, we're going to be doing something like thumbnail, thumbnail, quick start. It's not C, it's console, and we do here make, and then metaballs. So that's pretty much the entire thing we want to have in here, and yep. Add readme, release everything under MIT. Cool. Metaballs, public, boom. Add origin, I'm going to be doing that, and I'm about to push the metaball. That's right, we're pushing. And the shit has been officially pushed. Go grab it here, give it a star, give it a like, subscribe. And let's actually put that in the description. So this is basically the source code, right? This is basically the source code, right? Yeah, that's pretty cool. So that's the result of today's stream. It's a pretty scuffed implementation. On the GPU, it would be way faster, I think, of course. There's a lot of things that you can optimize in here, even on CPU. Yet again, you can use MATSHM to actually send the data faster between X client and X server, right? You can also parallelize the rendering, right? So you can split the whole screen into several chunks, and you can have several threads that render each individual chunk, since computation of these chunks are independent, right? We compute pixel by pixel. So, and this is something that we do in Wang tiles, actually. So, yeah, it's pretty cool. And it's also really fast when you enable all of the optimizations. I presume all of the optimizations will use SSE, like CMD instructions, right? And maybe among the CMD instructions you have square root. That's why it's so fast. It actually like feels like OpenGL, to be fair. It actually does. It's so cool. It's like very responsive. I really like that. All right, so I guess that's it for today, boys and girls. Thanks everyone who's watching me right now. I really appreciate it. I hope it was interesting. It was definitely interesting for me. We learned a thing or two. We even used like an actual legendary inverse square root. Everyone's talking about this thing, but nobody's actually using it. We went ahead, we took it, we used it, we demonstrated it fucking works. It freaking works, we demonstrated that. How many streamers and YouTubers do that? I didn't think so. They only talk about this shit. Nobody's using that. So yeah, thanks everyone for watching, and I gotta go. Check out all of the links and stuff like that. Thank you so much for the subscriptions. I really appreciate all of the support. I love you all.